We have another treat especial. Xinyu's here to tell us about the Cangjie language out of Huawei, part of the Harmony OS. I often hear people complain that we don't get enough papers and talks about language design. So if you've ever felt that, you are in for a treat. We've got one here. Please take it away.
Thank you. So this is Feng Xinyu from Huawei Programming Languages Lab, also from Nanjing University. So I'll introduce the Cangjie language at Huawei. Cangjie is a new programming language for mobile application development on Harmony OS, which is a new operating system for Huawei mobile devices. So with this new language, we can have a better vertical integration of the whole hardware and software stack to deliver better programming experience or performance to our developers. Also, the language itself is a general purpose language. It can be applied in other scenarios like microservices. So the language is a modern statically typed and garbage collected language. With ARVM-based backend, it supports native compilation. And it's also a multi-paradigm language. So the name comes from the ancient Chinese sage who is supposed to be the inventor of Chinese characters. So here we have a nice picture of this person, Cangjie. Here I'll list some of the key language features of Cangjie, including this algebraic data types and pattern matching, unbox value types, green thread, object-oriented programming, type extensions, macros, and effect handlers. I show the availability of these features in other languages. This is not intended to be a thorough comparison or a fair comparison, just to give you some idea how these features are adopted in other industry-level languages. This is a lightweight thread in Cangjie. We use this spawn keyword followed by a lambda expression to create a user-level thread. It returns a future type so that you can get the return value of this lambda. So the implementation is stack-based instead of stackless, so that at the programming level, we don't have to worry about this async await modifiers. It also supports dynamic stack expansion. So we have a low latency concurrent compact GC. This is quite important for UI intensive applications where people really don't want to have delays during the operation. So in the implementation, we introduce read barriers for global variables so that we can eliminate some of the synchronization points and reduce the delay of the stop the word period. And on the right-hand side, we have an experiment showing that the delay time for Cangjie, it's the blue numbers, which is usually below like 10 milliseconds. Most of the time, it's around 1 millisecond, so which is quite reasonable. I want to point out that the implementation is based on ARVM. It's a moving GC, so it could potentially be a good contribution to the community because it seems so far we don't see many mature implementation like this. And for performance, we did some experiment using the micro benchmarks from the benchmark scheme website. And we did this comparison with Java. It seems that the performance is at the same level with Java. And for some of the test cases, actually, it behaves even better. And also, one of the goals of the design is to have some kind of language extensibility. So we want to use Cangjie as a host language so that above this, we can build embedded domain-specific languages. So when we design the language features or the syntax, we try to make them DSL friendly, like operator overloading or microprogramming or some special kind of syntactic sugar. So with some experiments, actually, we can now support these different style of domain-specific languages embedded in Cangjie, like HTML or SQL or Prolog-like style programs. Also, we have a preliminary implementation of contract programming so that people can can use annotations of pre and post conditions and environments, and then do this some runtime testing. As an example of our domain-specific language, we also have an implementation of an agent DSL. We call it Cangjie Magic, which is now an open source project online. So in the language, we can have a simple configuration of an agent about the models and the planning strategy. We also have several prompt patterns provided to simplify writing prompts. Also, as a syntax for multi-round conversations with agents, and the framework also automatically maintains the chat history. We also, with operator overloading, we introduce is have a declarative style of multi-agent coordination. So next, I will spend some time to introduce the support of effect handlers in Cangjie and some of the applications. So many of us are already very familiar with effect handlers. So here in this try block, when we perform an effect, it's like throwing an exception. So we jump to the handler, and then we get this resumption as a first class value so that it can be stored in variables. It's like a continuation. Then later on, we can use this resume to jump back to the place where we perform the effects. So we know this is a very powerful language feature which can be used to implement all kinds of control abstractions like coroutines. But at the same time, it could be overly expressive. People may abuse this to write unreadable code. So that's why we also introduce a more limited form we call immediate handlers or resumable exceptions. Here, resumptions are implicit, so programmers don't have access to the resumption value. In the handler, they can only either drop the resumptions or do the resume immediately. So the resumption cannot escape the handler block. So even with this limited form, we found it's already very useful because this kind of dynamic scope of handlers, it gives us the ability to implement something like dependency injection. And also it allows more efficient implementation than the general form. So next I'll introduce some of the experiments we do based on these immediate handlers. So in our UI programming, on the left-hand side, we write code to configure the parameters of the UI components. Actually, for each line of the code, the underlying implementation calls the native C++ code. So as you can see from during the execution, so we always go across the boundary between Cangjie and C++, go back and forth. This introduces lots of performance overhead. To address this problem, the so-called FFI coalescing tries to intercept all these foreign function calls from the Cangjie side and batch them and forward them to the C++ side. So in this way, you only go across the language boundary once. Okay. And then we use this effect handler to collect all these function calls. So the idea is that in our original implementation, we do the foreign function calls directly, but now they are just effects. Then in our handler, we collect all these function references and arguments and put them in this list. And then after all the function calls are collected, we forward them to the C++ side. Okay. So the next application is to use effect handlers to do some kind of reactive state programming in the UI framework. So UI state changes require querying the UI tree to identify and update these dependent properties. So then to do this, we define these state operations as effects. And then so in this try block, we may access the states. And in the handlers, what we do is actually checking the dependency relation. And also we propagate these state updates along these dependency relations so to implement this reactive programming. And the next application is a domain-specific language, which is similar to CSS-style programming for component configuration. So here in the UI code, we can see that for the same kind of components, we usually have the same style configuration here. So it's a lot of redundant code. Actually, we try to define this kind of configuration as effects. So we do this configuration in the effect handler. This way, we can have this nested style definition, which is very similar to the familiar CSS programming. So these are the main language features. Next, I want to introduce some of the key challenges and the ongoing work. So the first one is about DSL programming. As I explained that we want to use Cangjie as the host language so that we may have embedded DSL, which means we want to support mixed programming of the host language and the DSL language. So in this example here, in this DSL program, it may refer to variables and types defined outside in the general purpose language. So the challenge here is to provide a unified language experience between its host language and DSLs. So another issue, which is also well known for people working on meta programming, so the problem is that we want to lift these error messages generated by the compiler for this general purpose host language to the specific domains. So in this example, this is a very simple example. The code on the top is trying to do some addition of vectors. So A and B are supposed to be arrays. But here, there's a mistake. So B is an integer. So the expected error message should be the complaint about type mismatch. But if we expand the code, expand the macro, actually we can see that the code below accesses the size fields of B. Also, it uses the indexing operator to access the elements. So we'll get complaints like there's no size field for integer type, or there's no indexing operator for integers, which would look totally confusing to these domain programmers. So the next problem is about cross-language interoperability. I think our previous work explained this issue very nicely. So the interaction between this managed language and C, C++ cause lots of memory safety issues. Actually, in Cangjie, this is also one of the major sources of memory safety problems, although Cangjie is supposed to be a memory-safe language. So to address this problem, we probably need some tools to support cross-language program analysis. Also, we need to introduce rich types, as also mentioned in our previous talk, to have a nice signature for these foreign functions. But here is another issue, which is the interaction between managed languages, which probably not so thoroughly studied. So here, Cangjie need to call libraries of other languages like Java or ArcTS. ArcTS is an extension of TypeScript, which is also an application language for Harmony OS. So here, in this kind of scenario, so both languages have their own garbage collectors. Then the garbage collectors need to cooperate. Then there's this nice PLDI paper actually pointed out that we may have several issues. Actually, these issues also show up in our in the real programs in our projects. So one of the problems is that the nodes, the objects may follow cycles on both sides of the languages. And then the garbage collectors may not be able to collect all these cycled nodes. So this causes memory leak. The second issue is that although there are no cycles, but if we have a long list of nodes which go across the language boundary, it will take multiple rounds of GC of GC on both sides to finally collect them. So it will slow down the memory collection. So this paper also proposed a nice mechanism called ref-graph GC, so which seems to be a nice solution for this problem. Currently, we are trying to have a prototype implementation, but the problem is it still doesn't have a good support of the paper doesn't show the concurrent implementation. It just stops the word implementation. So we want to study how to make this concurrent so that it doesn't cause more delays. Also, it would be interesting to study that the same process, the Cangjie side may want to interact with multiple languages. So it would be important to extend this mechanism to support interaction with multiple GCs. The third issue is for ABI stability. So high-level languages promise that we have a better abstraction. People usually don't need to worry about this low-level implementation detail. But if we care about separate compilation, or if we work on this cross-language interpretation, so we have to understand this binary formats, including this calling convention, memory layout of data types, or even name mangling. So, and these are the several scenarios that we need to care about this. So the application need to do this dynamic linking with the library, which is on the operating system side. So if the library evolves and the binary format changes, so the linking could fail. Or maybe the library is the same, but the compiler is upgraded, and we recompile the library, which may also break the compatibility of the binary format, so the linking may still fail. And then the third scenario is about the cross-language operation. So, so the problem here is that we have to be careful. If we want to give some kind of promise of this ABI stability, we need to be careful with the trade-off between flexibility versus performance. One way is that we hardwire all these ABI formats in our specification so that the compiler can still do the optimization. But then it would be too rigid for the compiler to make any changes. Or we can introduce some runtime resolution. So this gives us flexibility, but this also affects performance. Another issue is that we have to handle lots of this tedious low-level details. It will be important to have some systematic approach to describe or specify this ABI. So it was nice to see some of this work along this line. And also, it's important to have tools to do checking or testing of ABI conformance. So these are some of the problems that we feel maybe deserve more attention from our research community. And also there are other challenges and ongoing work, like we are considering introducing ownership types for better memory and resource management. And also we are building tools for this cross-language source-to-source translation so that people can import their legacy code to the new language. Also, we need some effective ways to do this compiler or runtime, including GC testing. And we want to minimize the compilation time with some incremental or parallel compilation approach. So there are also other problems which are on the list. So anyways, we have on the website, we have an online playground. People can try if you are interested. So feel free to try and contribute. This is the end of my talk. Thank you.
Okay, we've got time for a few questions. Any hands up? Let me see, and we'll bring the mic over to you. Oh, there's one.
Hi, this is Songan from NYU. I'm really curious about Cangjie being built with Harmony OS in mind. Are there any different technical considerations such as scheduling, because you're working now in a microkernel architecture rather than a monolithic kernel?
Yeah, actually, indeed, scheduling is actually one of the most feature that we want to have a vertical integration, so-called vertical integration. So one of the issues that we have is that applications may want to create too many threads. They may be selfish, and then the uniform system level scheduling thread management mechanism can have effective control of this. So the language wants to have a good coordination between with the system level scheduling approach.
Hi, Thomas Gilray at Washington State. Really enjoyed your talk. You mentioned that you're able to optimize these second-class resumptions for effect handlers. And I'm wondering if that makes the stack kind of like a zipper structure, or if you're using inlining, if you can speak to what you're able to do to optimize these, given that you don't have first-class control.
Well, I'm not an expert here, but I guess what I heard was that because this resumption doesn't even escape the handler, I think we avoid this stack copy or something. But we can discuss the detail offline. Yeah.
Hi, I'm Christine Riscala from the University of Melbourne. Yeah, thanks for your talk. I was curious if you have any plans, like for verification or that sort of thing.
Verification. Yeah. So actually, we currently we are trying to export high-level intermediate language, so which may serve as an infrastructure for program analysis, and also, so we also have some kind of collaboration with universities to have like formalization of the semantics, also maybe some of the algorithm.
Hi, John McCall, Apple. You said that you have growable stacks, but you also have C and C++ direct interoperability. How do you manage the stack problem, or did you also change the stack model in C?
We don't feel it's needed. We are doing this. Okay. I mean, in that case, you can't grow the stack. I think.
Oh, okay.
Yeah. Okay.
Let's thank the speaker again, and we'll switch over to Soonho next.